Okay, this is a video which will be an introductory video into the concept of VLANs and how we would need or why we would need VLANs. I'm using Packet Tracer to kind of demo this concept. So let's say that we start off and we have a router. So what I'll do is I'll grab a router. This is going to be a 3-port 4331 router. So if I open it up and zoom in, it's got the ability to have 3 gigabit interfaces, but you have to add an SFP module. So I'll go here and then I will just add that in. And now it should have 3 interfaces. And let's say we get a cloud and we have a cloud out here. And we'll say that one of these interfaces has an Ethernet cable. We'll say gigabit 000 has an Ethernet cable that goes out to the cloud. Okay? So that's the WAN connection or the internet connection. And then typically on a typical network, right, you would have essentially, right, you'd have the WAN out here, okay, off the router, and then maybe you would have connecting to a LAN. So we'll say there's a local area network. Okay, and then maybe if this is a company that has servers that are publicly exposed to the internet, or just exposed to the public internet, you might have like a DMZ or demilitarized zone for your servers. So to do that, typically what you would do is you would have some switches. So let's just let's grab some switches really quickly. So I'll grab a couple of switches. Okay, there's one and there's the other. Okay, so I'll plug those in. So we'll say gigabit 001 to gigabit 01 and gigabit 002 to gigabit 01. So there you have it. Now we have our DMZ over here and we have our LAN over here. And then we would have, let's say, a few servers over in our DMZ. Maybe we're serving a website. Maybe we're serving, we have a DNS server or something like that connected to these servers. Or maybe we have some specialty services that are part of our company. Maybe there's some type of database and then over here we have the users on our local area network. We have PCs over here. Okay, so these are separate networks. These are separate networks. So for instance, if I say these are separate networks, what I mean is that if I grab kind of a color tool here, and we'll say fill color, and we'll say green, and we got a circle with no outline, and we say, okay, this is the LAN, okay, and this is going to be orange because it's not a safe zone, it's the demilitarized zone, so it's kind of orange. All right, so there's the DMZ. And then we'll get a reddish color to indicate that this is basically the WAN. So this is the danger zone, this is the safe zone, and this is also basically a danger zone because it's the DMZ, so it's publicly exposed. Right? So you have 3 different networks in this scenario. You have 3 completely different networks, and they would have a different network address space. So we could say that our LAN here is a 192.168.0 network, something like that. And we could say that the DMZ over here is it's a different network. We use a completely different address space for this network. So we could say that our DMZ is a 172.16.1.0 network. So that's a completely different address space for our servers. And then the WAN out here, we'll use our trusty Cisco Academy address range 209.165.100.0/24 to indicate that this is this is our WAN. And I'll just fix that really quickly so that it follows the pattern here. So we've got the WAN, and we've got the LAN and the DMZ. So those are completely different address spaces. Now, in this scenario, it's really easy because all of the switch ports that connect to all of the PCs and then connect to this router interface can all be part of the 192.168.0 network. And so they can all be part of essentially the same VLAN. And this network here can be its own VLAN because all of the ports are being used by the servers, right, in that network. So we have a switch for the DMZ, we have a switch for the LAN, and then we have a direct connection, let's say, out to a modem to get to our internet service provider. All right, so that's, that would be really easy. So to set this up, we would go to the router and go to the CLI, and we would say enable T, get to global config mode, and we go, oops, I need another 0 here, and we'll just quickly set up the IP address. Okay, and there, give it the IP address and a no shut command. And yeah, I put that on the wrong interface. All right, whoops. So we'll just change that to 172.16.1.1. Okay, there we go. Now that's the right interface. And then we will go to interface gigabit 0/0/2. And this time I'll make that one the right IP address and then no shut. And so now the 172.16.1 network is over here and the 192.168.0 network is over here, and everything's hunky-dory. And all of the switch ports, you don't need to touch the switch ports. They can all be in their default VLAN. All of the switch ports, right, on a switch, if we look at the switch here, all of these switch ports, right, are in the same grouping. And what I mean by the same grouping is they're all by default in VLAN 1. Okay, they're assigned to VLAN 1 by default. And if you don't believe me, we just click on the switch, go to the CLI, type enable, and do the command show VLAN, and you'll see with the show VLAN command, right, which I just did, show VLAN, that VLAN 1 is the default VLAN. There's some other default VLANs that you cannot delete, and by default, all of the switch ports on the switch are in VLAN 1, the default VLAN. This is here to basically group, it's a grouping, essentially. It's a way of saying all of these ports belong in the same network. All of these ports belong in the same broadcast domain. It doesn't matter what the network is, whether it's a 192.168, 172.10, they're all in the same grouping based on this VLAN. Okay. However, right, what if, and this is a different situation, what if your company didn't have enough money for 2 switches? So I'm going to show you that situation right here. Let's say your company, they want a LAN, they want a DMZ, separate networks, and they want to have a connection that goes out to the internet, but they can't afford 2 switches. So what they have is, just so happens, all they have is 1 switch. Okay? They have 1 switch. That's it. And all of the switch ports are in the same grouping, VLAN 1. Right? Well, we only have 1 switch. Well, is there a way where you could say, hey, can I put half of the switch ports, let's see here, can I put half of these switch ports in VLAN 1 for one network and put the other half of the switch ports in a different VLAN for a separate network? Because, it turns out I only have 2 servers. let's say I only have I have 2 PCs. You know, can't I just group these into 2 separate groupings so that you know, my LAN, they can go on these switch ports, and then my DMZ, they can go on these switch ports, or something like that, right? And you know, I got some extra ports there for growth for my company, blah blah blah. Yes, you can do that. So what we could do is we could say, all right, so we'll say that maybe on this switch we'll put, you know, ports 12, let's see, 13 through 24. The second half of the ports, 13 through 24, we'll keep those in VLAN 1 for the 192.168.0 network, and we'll make a separate VLAN for the DMZ folk, and we'll call that VLAN 2, right? Okay, so what we would do is, right, and then also we still need 2 connections, let's say, to the router, or we'd want 2 connections. So we'll put here in gigabit 001, and we'll go here to gigabit 002. Okay, so we still have, we have 2 connections here. One is to gigabit 001 or gigabit 01, the other one to gigabit 02. So here goes. What we want to do is turn the switch into 2 groupings so that, let's say, this server connects to port, let's say 1, and this server connects to port 2, and we want the first 12 ports to be in a separate VLAN. Okay, then the other ports, right? And these guys already happen to be connected to port 21 and 22, so that's perfect. All right, so how could we do that? Okay, well, we'd go into the switch and we'd say, okay, in the CLI, we'll go to global config mode. And we'll say, all right, we want a different VLAN. So we're going to make a VLAN 2, and we're going to give it a name that says DMZ. So we know that VLAN 2 is for our DMZ computers. So there we go, that's done. So now we need to put the switch ports into VLAN 2, because all the switch ports right now, once again, Control C and do a show run, all the switch ports, right, are in VLAN 1. Actually, not a show run, show VLAN. That's what I wanted to do. Yep, VLAN 1, all the switch ports are in VLAN 1. But notice now we have a VLAN 2 named DMZ. Okay, so what we could do now is say, all right, we want to get those other switch ports. So the easiest way to do that is to use a special command called interface range, and then we could say F0/1, right? I think we can do -24. No, -12. We want only ports 1 through 12. Okay, so now I'm in global interface configuration mode, but for a range of switch ports, fast Ethernet 1 through 12. And what we're going to do is we're going to say switch port access, switch port, let's see here, switch port access question mark, and we'll say VLAN 2. Switch port access VLAN 2. So now these first 12 ports are in VLAN 2. All right, just that simple. So we did it. But we also have to do it for the gigabit port that we're using here, which happens to be gigabit, let's just double check here. It's actually gigabit 01. Okay, I think that's the one we want to use. Right. I think that is the one we want to use. Yeah, 01. Let's see, which one does that connect to? Gigabit 001. Let's just hover over this sucker to figure it out. We'll hover over it. gigabit 001. That's it. So 01001 is connected to 01. All right. So we also want to say we also want to go into interface gigabit 0/1 and also put that one into switch port access VLAN 2. All right, so now the first 12 ports are in VLAN 2 and as well as our gigabit port. If we look on the switch here and say show run, nope, not show run, sorry, show VLAN, you can see that now ports 13 through 24 and gigabit 02, they're all in VLAN 1, but ports 1 through 12 and gigabit 01 are in the DMZ port. So basically, we've put the switch ports on the switch into two separate VLANs or two separate groupings. That's essentially like turning the switch into two switches, so that it's like for two separate networks. So only ports 1 through 12 can talk to each other, and only ports 13 through 24 can talk to each other. And the two sides cannot communicate. The two networks cannot communicate without a router. But it just so happens that we have configured, right, a port that goes to the router and another port that goes to another router. And those two ports on the switch are in two different VLANs. Now, we can look at the router here and do a Control-C and do a show IP route to look at the routing table. And if we look at the routing table, we see there's the 172.16 network for our DMZ, right? It's directly connected on gigabit 001, and there's the 192.168.0 network, and that's directly connected, that's directly connected on gigabit 02. So now we have two networks on our router. Actually, we have three networks with the one that's going to the cloud, even though it's down. And we have the DMZ in this. So essentially, we've taken the switch and divided it into two separate groupings for two separate networks so that broadcasts stay in that network. And you could see that, that's the case. So what we'll do is let's configure these PCs and try to send a message from the LAN, let's say, to the DMZ, which is something separately you'd want to block, because you'd want to block traffic from the DMZ to the LAN, but you should be allowed to talk from the LAN to the DMZ and then back again. But you don't want to be able to initiate communications to the LAN, and you don't want to have the WAN initiate communications to the LAN. Only the LAN can do that. The LAN can talk to the internet, and then that can come back, and the LAN can talk to the DMZ, and that can return. But it can't be initiated from the outside. That would be a security risk. All right, so let's do it. So we say, okay, this PC right here, and we'll say 192.168.0.10, and the gateway is .0.1. All right, perfect. And we'll just test, can we ping the gateway? And because we want to test right off the bat, can we ping that gateway? Come on. All right, we can't. All right, so what is the problem? Let's see here. I think we have the wrong switch port here. Gigabit 01. I think we have the wrong switch port. I think gigabit 01 here if you can kind of see it, is connected to gigabit 002 on top, right? And gigabit 002 on top, that is the one on the 192. So I think we actually got it backwards. So let's go into the switch and we'll take a peek. Show running config. We want to look at our running config, and we're troubleshooting this now, which is okay. This is part of it. Okay. So gigabit 01 is in VLAN 2. I think it needs to be backwards. I think that 2 needs to be in VLAN 2 and 1 needs to be in VLAN 1. So how do we rectify that? Okay, so to rectify that, we say interface gigabit, no, we go to global config mode, interface gigabit 0/1, and say no switch port access VLAN 2. And then we could say switch port access VLAN 1, which is the default, which is what it would go to anyway. And then we'll switch this around. We'll say gigabit 2, this is the one that needs to be in VLAN 2. Okay, so I just switched those. So now they've changed. I'll fast forward time. It's really important to know which one you configured. And now if I ping, you can see I can ping the router. So my mistake is that with all these little labels here and this little visual representation, right, I thought that gigabit 01 was the one connecting the DMZ to the router on the DMZ port, but it was the opposite way. So now you can see that I can ping the gateway. So that works well. So we'll go here, we'll set up the other PC, 192.168.0.11, and there we go. There we go, there's the gateway 0.1. Okay, and that should be good. I'm not even going to test it because I know it's good. And then over here are two servers. So this server is at 172.16.1.100, we'll say. And we want a 24-bit subnet mask. And the gateway 172.16.1.1. All right, that looks good. We go here. Can we ping our gateway? We can. Great. So then, knowing that, I go to the other server and configure the other server. We'll say he's 101. Fix the subnet mask and put in the gateway. Okay, so our PCs and servers are configured. These two guys are in the 192.168.0 network. We have host 10 and host 11. And then over here we have 172.16.1 network. And we have host 100 and 101. Okay, now watch this. So we say, all right, simulation, show none, edit filters. We want to see ICMP. Okay, so we're going to ping. So we click here on this packet. Say let's ping from PC1 to server 1. All right, there it goes. The ping's ready to go. So I just say click, and there it goes. It hits the router on VLAN 1 port. It goes from the router's gigabit 01, which is also on VLAN 1 port. It comes back out of the router. Whoops. Failed. Okay. Reset simulation and go. There it goes. Goes to the router. Comes back on the other one. Goes to, notice that it was broadcast to both devices here. It ended up going, because this is this is where we're going eventually. Reset simulation. We're having a tough time on this. Okay, there it goes. Goes to the router, comes out the other port, and goes over to the 172.16 network, where it goes to our intended destination, the server, and then the server replies back to the ping with a pong, and goes back up to the router. These are all VLAN 2 ports. And then down the VLAN 1 port, over to the VLAN 1 port, and to the PC. So basically, right, you have the ability to turn that switch into 2 switches, basically by saying, hey, these switch ports are in a VLAN 1 grouping, the other switch ports are in a VLAN 2 grouping, and that essentially says that, hey, those 2 groupings, right, they're within the network. Broadcasts do not leave those switch ports. You cannot communicate from one VLAN to another VLAN without the use of a router. So we have a router where the connection is on one VLAN connecting to the router, and then it comes out the other interface on a different network to a different VLAN connected to the switch. And then so you have that segmentation of the switch into basically an effectively 2 separate switches for 2 separate networks.